Okay, the next two topics we're going to talk about in chapter 11. Again, this will be on the test next Monday, but we're going to take a look at two different things. Up to this point, we've worked with good old-fashioned plain text files. And a text file is something that we can use a text editor for. Text editor, Notepad is a good text editor. Office Word is not, because there's so many invisible characters. JGrasp is a text editor. So anything, Neovim, I'm guessing that's a text editor. Okay, so we have lots of different text editors that we can do simple things with. But when I'm working in the computer science world, and it's becoming more and more in the front of the programming world, is this big data, working with large amounts of data. And you did at the end of CPS 121 if you had me, because you had a set of almost 1,500 pieces of data to work with. But the world of big data is coming. And so one of the things that you're going to be doing more and more is working with data files, and text files aren't the best option because you need to do more conversions than with one of these two choices, either a binary file or something that's called a random access file. So the binary file is going to be a benefit because it's going to store it in, down here I have a note, raw binary form. Okay, so it has this raw data in, and you can kind of open it with a text editor and look at it and get a feel for some of it, but not necessarily all of it. So it's not as easy to look at or edit. Definitely don't want to try editing it. Okay, that goes way back to when my students back in the 80s were playing A Bard's Tale, and we were able to look at the data files, and they figured out where money was, and then they had to figure out in binary form how to change it so they had a lot of money so they could buy the bigger weapons and beat everybody and the game was over, kind of deal. But it's a binary file. The second thing we're going to take a look at today is this random access file. And this is one that you're going to like because it's different than anything we've done before. When I work with a binary file or a text file, we would start at the beginning and move across the file doing what we need to do. Reading in from the file, writing data to a file, okay? The random access file is going to be a little bit nicer in that I can jump to locations wherever I want to jump to. And the program we're going to write at the end of class today is going to work with a random access file. So this one's kind of nice. It lets me jump around, jump up, never mind. Okay, so coming back to my binary files. When we were storing things in a text file and I wanted to store the number 1297, storing it as characters, I would take up, I'd have to put it in here, a character's 2 bytes, so 2, 4, 6, 8 bytes kind of thing. So I used 8 bytes of memory, and I was able to store it. Okay, and again, this is going to need some conversions when I'm working with it. If I take a look at the second one, if I'm able to store a binary file, when we look at it, it won't be zeros and ones. It could be smiley faces, it could be 8s, it could be lots of different things. But in raw binary form, it stores it like you see here. Now, tell me about what you see here. Don't say it's more efficient and it's less conversions, because I'm already telling you that. What is this in here? First of all, this is 2, 4, 6. How many bytes? Because each character takes up 2 bytes of memory. So that's 8 bytes. Yeah, thanks, Harrison. The one guy who can't talk is the one with all the answers. When I look over here, I'm using up how many bytes? I'll start picking on people. Just 4. Thank you. Yeah, because this is 8 bits, 8 bits, 8 bits. This is also storing the number. What is this number? A 1, 2, 4, 8, a 16, 32, 64, 120, a 256, 512, and 1,024. So if you added those numbers up, I would actually get the number 1,297. So this is the binary form representation of the number 1,297. If I stored it as characters, it would look something like that. Okay, so let's talk about how I get ready so we can reduce them to base 10 numbers. Yes, yes, and yes. That is correct. And of course, we've done the whole conversion because our first selected topic was dealing with base 2 numbers. So when I was doing the 1, 2, 4, 8, 16, you should have all been able to follow along. All right, so I want to get ready and I want to write to a file. I had my little opening of the file and then getting ready to write the data to the file. I have a layout of creating this first instance, creating fstream. There's an object fstream. It ties into the name of my data file. Then I create another instance. This time my object is output file, and it's going to make, this stands for data output stream. You saw it all in the textbook because you did code listing 11.3 and you did code listing 11.13 and code listing 11.14. Again, working with files, I have throws IO exception. First step, get it ready, create 2 objects, get it ready to be written to, right? Output stream. I write to the output file. This time I want to write an integer. So this would store it in binary like we liked before and closed it. Hopefully you did type this in. Not everybody did. You ran it and you took a quick look to see, did it in fact work? What did the binary file look like? Was it readable? Now in this line, I have output file dot write int. Here was the whole list, right? There were no code listings due. Okay, so at least you got the idea of, look, did we do 11.13 the other day for the last code listing? Was that part of it? Okay, so in your chapter 11 code listings, that was part of it. When I want to write to a file, I write Boolean, write byte, write all of these. The interesting one comes in down here at the very bottom. When I want to write a string, I need this Unicode text format, this UTF, because it's got to do some funky work with strings. Because remember, string is not one of my original data types that we worked with. Okay, so 11.13, getting ready and writing this data. It should have wrote 2, 4, 6, 8, 10, 12, 14 to the data file. Doesn't mean you were able to understand it, but that's what it was. 11.14, we're getting ready, and this time I'm going to, 1, get it set up to input. This time I want to be able to read from a file. Okay, again, this is storing everything in binary file. We still have the while not end of file marker we can use. We have reading in from the file. And of course, we always want to make sure, but it's now on the next page, that we close the file. Little extra try and catch block here. Writing and reading, binary files. And again, make sure you keep an eye on that UTF when you're working with strings. And again, I have a note up here, string name equals Chloe, output file dot write UTF name. Just the same, if I'm reading, I need to store it in a string. All right. End of binary files. Nice, cute, neat, but we can have more fun with what we're going to talk about next, and that's these random access files. As I mentioned earlier, all the files we've done have been sequential. We started at the first piece of data We worked all the way to the last piece of data. We had that linear approach. Well, when we start talking about random access file, we're going to be able to access the files at whatever location we want. But some things are going to become important. Before we get to that, when I'm working with a random access file, I need to have a mode as one of my parameters. So if I take a look at this random access file, here is my file name as a string, as always, but I'm going to include a mode. In the modes, you have two choices. One is R and one is RW. R is for read only. We could make everything RW. I would rather sometimes use R so that I don't accidentally screw up the data file. So the reason for read only is so you don't screw up the data file. And again, the RW will allow you to read and to write. Now, a lot of you have heard me say this before, but if our author is doing bullets, it's usually a good thing. Here's some things to remember about the two modes. If you open it at R and it doesn't exist, you're going to get a file not found exception. If you open an R and try to write to it, you get an IO exception. Some of you are starting to go, oh yeah, there was a class called file not found exception. That was my whole inheritance thing. Here's IO exception. I know that's a problem, right? So that exception could be thrown. If you open an RW and what contents are already in the file won't be deleted. Before, when we wrote something when we opened the file to write to it, everything would be deleted. If the file didn't exist, it would be created. Here, again, if it doesn't exist, it will be created. But unlike before, when I open a file to write to it, it won't be destroyed and that pointer put at the beginning and nothing after it. It'll go to there. All right, so this code listing 1115, I have it highlighted, so I think you probably typed it in. You were going to get ready and you were going to fill a random access file with this array of characters. Okay, so let's see how we do this. We come in and random access file, working with a new class called random access file. Instantiate an object, random file. We're going to link it to the data file letters ... If it doesn't exist, it creates it. If it does exist, it just puts this pointer, not a pointer in CPS 162 cent, but this little pointer at the very beginning to get you to write to it. This now comes in and goes through the file from start to end. So again, I'm using random access file this time. Nice and simple. It writes them into a file. As always, we need to make sure we close the file. Now that sounds a lot like a binary file. Well, it is, but now we also have a file that we're going to be able to take advantage of this thing called a file pointer. And what a file pointer does is it's going to allow me to jump around the file. And that's the whole benefit of these random access files. Okay, so when I get started, the file pointer holds the byte number of a location in the file. So what exactly does that mean? It holds the byte number. Well, I can look and notes. First of all, I have one file pointer is that the bytes in the file start at 0, and then we'll go 1 byte at a time. But one of the things to remember is when I'm working with the random access file, I want to know what type of file it is. Because if it's a file of characters, when I get in this random access file, I want to be working in groups of 2. So as I move, I want to move in blocks of 2. And this is a better drawing. I didn't feel like drawing it. But if I was to store some characters like A, B, C, D, A would get stored in this first block, which would be 2 bytes. So the first character would be stored in 2 bytes. B, the second character, would be stored starting at location 2 from the original address. So this is a lot like strings again. I'm going to be moving certain amount of blocks each time. or not strings, excuse me, arrays. It's going to be moving like arrays. I'm going to be jumping. So if it was bytes, every character would get. So if I wanted to get to the 5th character, I'd need to go to the address and move over 10 bytes. 6 characters, 12 bytes. 7 characters, 14 bytes. So if I want to get to a certain character, like the 12th character, I'd need, well, to get to 7, I went for basically 12 times 2. I need to move over 24. So when you start looking here, you see I need to make sure I know what the character size is, and that's 2 for 2 bytes. Just like I would need to know an integer. That would be 4. So I'd be moving in blocks of 4 bytes. All right, so in here, if I want to get to the 5th character, I move 2 times 5, or I'm going to use this method seek to move my pointer over 10 bytes so that I would get to the 5th character. Once I move it, I can read it in. Read char. Okay. I have code listing 1116 up, and if I'm taking a look at it, if I want to move to the 5th character, I'm going to move over 10. I'm going to read it in, print it out. If I want to get to move to character 10, which would actually be the 11th, are characters always 2 bytes? Yes, they are. Characters are 2, integers are 4. The UTF is crazy because it has to do that conversion with strings, and I'm not exactly sure how all that works. So if I take a look at my data file, and I'm moving over, I'm getting F, K, and D by how far I move this seek pointer. So again, I can move linearly. I can jump around if I want. 2 choices with my random access file. And again, this code listing 1116 is good to show me how to jump around a little bit. And this code listing 1115 was good because it showed me how to go through linearly. All right, so I double checked my notes, but I think I hit everything. This whole idea of jumping, since there are characters, 2 times 3, and so on. Da, 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 da. Let's see what we got. If I take a look at D2L, I now see I have a program. This project really is going to be 3 programs. First program is I want you to store these characters in a random access file. And what I gave you down here in the bottom, this writeletters.java, is going to help you. That takes number 1 and does most of the work for you. You just have to write those letters to a binary file. Questions? The second program you're going to write is going to open your binary file. Okay, it's going to, well, excuse me, your random access file. You're going to open your random access file. You're going to go through linearly. If the character equals a P in the file, you're going to replace it with an E. Also, as you go through, if the character is a Q, you replace it with an A. If the character is a Z, you replace it with an O. So that's your linear progression through a random access file. Then you're going to use seek. You're going to replace the 4th character with a V. You're going to jump to the 16th character, replace it with a W. You're going to the 21st, replace it with a D. 26, replace it with an R. Then when that's done, you're going to write a 3rd program, which opens the file and prints everything out so you can see what the secret message was. First program, almost done for you. Write letters. Second program, modify your data file. Third program, you're going to display the secret message. Questions?